This will be the tutorial for section 4.1, and I'm going to try and get through problems 12 through 30. We'll be doing every third problem. I may break this up into several videos depending how long it takes. Number 12 says, use analytic methods to find the extreme values of the function on the interval in which they occur. Okay, so they want us to use analytic methods, which means pretty much back up whatever answer you get with math. At no point am I asking you to forget what you already know about a graph such as e to the negative x. We should know that the graph of e to the negative x, I'll just move out of the way over here, e to the x would be growth, so e to the negative x would be decay. Number 12 asks us to look on the interval from -1 to +1, including the endpoints. And so it's pretty clear that we already know the answer. The maximum will occur at -1 and the minimum will occur at +1, and it won't happen at any of the interior points. There is no point within the graph on this domain where the slope is 0 or undefined, so we know there won't be any critical values. So frankly, we already know the answer. It's going to be the maximum will be at -1, and it will be a value of e to the first, and the minimum will be 1 over e. So let's just have the math show us that. We already knew we were going to have to check the endpoints. So we already know we're going to have to find g of -1 and g of +1. And g of -1 would be e to the negative first, so that's just e. And then e to the -1 is 1 over e. Alright, so even if you don't know the graph, we should come up with these answers. And now we look for critical values. And again, I'm not expecting to find any. So we take the derivative of g, and the derivative of e to the negative x will be e to the negative x times -1, or simply negative e to the negative x. So the critical values, we want to know when this function equals 0. So when does g prime of x equal 0? And so we set the derivative equal to 0. Divide by negative, and I get 0 equals e to the negative x. And again, we should know that e is never going to equal 0. We can, continue solving this, using logarithms. So we take the natural log of the left side, and I take the natural log of the right side, and the natural log of 0 cannot be done. No solution. And so we don't find any place where the derivative equals 0. Now we also need to look at when is the derivative of g undefined. And this is kind of an interesting question because there are lots of places where the derivative is actually, let me rephrase what I was going to say. I was taking this a different direction. So now I want to know, when is e to the negative e to the negative x undefined, and there is no value of x that I can't plug in. Everything can be plugged in and we will get an answer. So we get none here. So there are no points where it's undefined. We found no values where it equals 0 because I wasn't able to solve the equation when I set it equal to 0. And so that means we found no critical values. So the points I need to check are the endpoints, and then that's it. And so once again, we already knew this answer, and the math has backed us up. The maximum, so let's just write it out formally here. The maximum is e, and that occurs at x equals -1, and the minimum is 1 over e, and that's at x equals +1. All right. So then we move on to number 15. That's the wrong button. And once again, no one is asking you to forget what you already know. We know what sine looks like, and hopefully we know that the graph of sine of x plus pi over 4 would simply be the graph of sine shifted over. And so I know that sine normally looks like this. And so now the graph that we're interested in would be everything shifted in the negative direction pi over 4. This is pi over 2, so basically we're shifting halfway to the next point. So this point comes here. This point comes about there. This is there. That point moves there, and this point moves here. And they want us to look all the way up to 7 pi over 4, which would be a pi over 4 shy of 2 pi. So that means my graph should look like this. So once again, I already know the answers. I can write them down right now. The maximum is going to be 1, and that's going to occur on this interval at x equals pi over 4 and 7 pi over 4. The minimum is going to occur, well, it is a value of negative 1, and it's going to occur at x equals right here, which is going to be, where are we? We're at pi over 4 to the left of 3 pi over 2. So that's going to be 3 pi over 2 is 6 pi over 4, so that should be at 5 pi over 4. And again, all I'm doing is knowing the values of sine normally and then subtracting pi over 4 from those values. So I already know the answers. Okay. And again, let's see if we can get the calculus to back us up on this. And so let's, we already know we're going to check the endpoints. So I already know I need to check f of 0, which is going to be finding the sine of pi over 4. Plug in 0. I know I need to check f of 7 pi over 4, and that's going to equal the sine of 7 pi over 4 plus pi over 4 is 8 pi over 4, or 2 pi. So I know I need to check these values, and it occurs to me I've already made a mistake, which is unfortunate because I don't want to go back and edit this. I ended my sine value, I'm over here at the graph, I ended it here. That's not where 7 pi over 4 is. Here's 2 pi right here. So 7 pi over 4 is actually this blue value right there. So it's ultimately not going to change my answer. My at maximum is still going to occur where I said it was, but now not at 7 pi over 4, and my minimum is correct. Alright, so sine of pi over 4 is the square root of 2 over 2, which is, I believe, 0.707, and the sine of 2 pi is 0. So I know the value of my endpoints. Now I need to find critical values. So the critical values occur when the derivative equals 0. So we need to take the derivative. The derivative of sine of x pi over 4 is cosine of x plus pi over 4 times the derivative of the inside, which is just 1. So now I need to figure out when it's equal to 0. and I will take the I took the derivative, so now I need to solve. And when is cosine of something equal to 0? So cosine of, I know that if we look at a graph of cosine, which I'll sketch in down here, we start at 1, so we know that we're going to be 0 at pi over 2 and at 3 pi over 2. But that's not what x equals, that's what x plus pi over 4 equals. So now I just need to solve for x, so I subtract pi over 4, and so pi over 2 minus pi over 4 is pi over 4, because pi over 4 is just half of pi over 2, and I subtract pi over 4 from here, and I get x equals, let's get a common denominator, 6 pi over 4 minus pi over 4 equals 5 pi over 4. So I don't know if these are min or maxims yet, but I know that they're critical values which I need to check. So I come back over to my list of things I'm checking, and now I need to check f of pi over 4, which gives me sine of pi over 4 plus pi over 4 is pi over 2. And sine of pi over 2 we know is 1. And f of 5 pi over 4 is sine of 6 pi over 4, which is 3 pi over 2. And sine of 3 pi over 2 is negative 1. So, as we sort of knew from the beginning, my endpoints are not the min or maximum. I have a value of 1 and I have a value of negative 1. And so the maximum is pi over 4. Well, the maximum is 1 at pi over 4, and then the minimum is negative 1 at 3 pi over, at 5 pi over 4, excuse me. Okay, we're at 12 minutes. I'm going to stop this video and we'll pick it up with number 18 on the next one.